Hello again. In this video, I'm going to go over section 2.4, which is on infinite limits. Okay, so let me explain what an infinite limit is first. So suppose you have a function, f of x, whose graph looks like this. And let's look at what happens to the y value for this function as x approaches a from both sides of a. So let's say you approach a from the right-hand side of a. I think you can see that the y value is just going to get larger and larger as that happens. So it's approaching infinity, right? The y value is, as x gets closer to a from the right-hand side. But that's also the case if you approach a from the left-hand side, right? The closer you get to a from the left-hand side, the bigger and bigger the y value gets. Okay, so in a case like this, the way we would notate this is the limit of f of x as x approaches a from both sides of a, because this is a two-sided limit, is equal to infinity. Okay, and that's called an infinite limit. Okay, notice you can also say the limit doesn't exist because in order for a limit to exist, it must approach a finite number. And so in this case, it's approaching infinity, which means it's not approaching a finite number. And so it would be sufficient to say the limit doesn't exist. But the reason it doesn't exist, if you want to be specific as to the reason why it doesn't exist, you would say that it's approaching infinity. Now, it could also be the case, let's say your graph of your function looked like this. It could also be the case that as x gets closer to a, the y value just gets smaller and smaller. And that's true if you approach a from the right-hand side or the left-hand side in this example. And so in this case, we would say the limit as x approaches a of f of x is actually negative infinity. And again, that means the limit doesn't exist. Okay. And so that's another example of an infinite limit. Okay, and notice again, both of these are two-sided limits, right? So this two-sided limit is infinity, and this two-sided limit is negative infinity. Okay, but it could also be the case where you have one-sided limits that give you limits that are equal to infinity or negative infinity. So for example, say your function looked like this, and you approach from just the positive side of a. So as x gets closer to a from the positive side, I think you can see that the y value is just heading towards infinity. And so the way we would notate this would be the limit of f of x as x approaches a from the positive side of a. So we would put a superscript, a positive for the superscript here. Okay, and then that would equal infinity. Okay, so, but it's also possible, let's say you approach a from the positive side of a, but the y value just heads towards negative infinity. Then you would notate it like this, where you, as x approaches a from the positive side of a, the limit of f of x is actually negative infinity. So here's, both of these are one-sided limits that are infinite limits. And then the other two possible cases would be you could approach from the left-hand side of a, which you would denote as x approaches a from the negative side of a, right, with this negative superscript. In this case, I think you can see that as that happens, the y value is heading towards infinity. Or it could be the case that you approach a from the negative side of a, which you would denote like this. And as that happens, you can see that the y value is approaching negative infinity. Okay, so this is really four different examples of infinite limits that are one-sided limits. Whereas up here, these are two examples of infinite limits that are two-sided infinite limits. So you can have both. Okay. So just be aware of that. Okay. Okay, this leads us to this idea of what's called a vertical asymptote, which you may have seen before, but we're actually going to formally define what it means to be a vertical asymptote. Okay, so the actual definition of a vertical asymptote is essentially if you have any one of these limits as x approaches a that are equal to infinity or minus infinity, regardless of whether it's two-sided, one-sided, uh, or well, from the left side or the right side, or two-sided, if that happens, then the number that x is approaching, x equals a in this case, ends up being what's called a vertical asymptote. Okay, so this limit as x approaches a of f of x, if it's plus or minus infinity, then x equals a, the number that x is approaching, x equals a, is said to be a vertical asymptote. And so that's true if you have a two-sided limit that's an infinite limit. But it's also true if you have just a one-sided limit that's an infinite limit. In this example, or in this case, you're approaching a from just the positive side of a. Okay, if that as x approaches a from the positive side of a, if f of x goes to plus or minus infinity, then you also have a vertical asymptote at x equals a. And then the other possibility is if you approach a from the negative side of a, if f of x goes to plus or minus infinity, then you also have a vertical asymptote at x equals a. So all you need is one of these three cases to occur, and that's when you have a vertical asymptote at x equals a. Okay, so example 2 kind of illustrates this idea. G of x is equal to this function right here. The graph of that function is down here. So that's the graph of it. And you can see from the graph that this graph has two vertical asymptotes, one at x equals 1 and another at x equals 3. But let's check this using the definition. So in order for x equal 1 to be a vertical asymptote, one of these three limits would have to be either infinity or minus infinity. Okay, so if you look at 1, I think you can see that if you approach 1 from the right-hand side, it goes to infinity, and if you approach it from the left-hand side, it goes to infinity. So this is a case where the limit of g of x as x approaches 1 from both sides of 1 happens to be infinity. And so that means x equals 1 is a vertical asymptote by the very definition, right? It's actually in this very first case where the two-sided limit is equal to infinity. Now, we also have this other vertical asymptote at x equals 3. And there's actually a couple of ways of seeing that this is a vertical asymptote. One is you could approach you could approach 3 from the positive side of 3. And I think you see as you approach from the positive side of 3, the limit is infinity. And so because of that, you can automatically say that x equals 3 is a vertical asymptote. Because if this one-sided limit is infinity or negative infinity, then it's a vertical asymptote. Okay, and then the other side, if you approach from the negative side of 3, I think you can see that it's approaching negative infinity. And again, that would fall under this case where you're approaching from the negative side and you're getting plus or minus infinity for the limit. In this case, it's negative infinity. Okay, so you just need one of these three cases to occur in order to get a vertical asymptote at x equals a. Now, as a side note, just if you're curious, what would be the limit as x approaches 3 from both sides in this case? You can't say it's infinity because in order for it to be infinity, you would have to be approaching infinity from both sides. And you can't say it's negative infinity because it would have to be approaching negative infinity from both sides. So the problem or the issue here is from one side, it's heading towards infinity. From the other side, it's heading towards negative infinity. So what do we say about the two-sided limit in that case? Well, the limit as x approaches 3 from both sides in this case simply doesn't exist. We wouldn't say it's infinity and we wouldn't say it's negative infinity. It would be wrong to say that. But we can say that it doesn't exist. So that would be the appropriate answer for this two-sided limit as x approaches 3. It simply doesn't exist. Okay, so I hope you found this video helpful. In another video, I'll finish off and do the second part of 2.4. Thank you for watching. Bye-bye.